In 1994, Lotus put its faith and its future in a revolutionary new sports car. Developed in record time on the tightest budgets, it would showcase technologies which could revolutionize the automotive industry. This is the inside story of Project M111. The Lotus 7 was a revolution when it was launched in 1957, delivering racing car performance at production car prices. It's become an icon, an enthusiast's car, the epitome of high performance achieved through lightweight rather than sheer power. But when Lotus looked to recapture its spirit in a new car for the 90s, inspiration came from an altogether different source.
I don't treat it at all as transport. There's nothing to do with it. You're riding around on something which is all tidy inside, you know? It's like a beautiful woman with a nice personality.
It's so clear-cut in its execution. It makes such a strong statement about what it's about. And, I mean, along with that, the same statement about its owner.
If you take the clothes off a Ducati, you see lots of nice things.
They are the best, no doubt about it. They've got a great racing history, and they look fabulous. And they've got a real sort of jewel-like quality about the way put together. I mean, you know, it's just a nice piece of kit to have. Everything's down to lightweight, beautifully engineered, and its whole purpose is to be this this motorbike which they make for the road, but it's actually a racing machine. And that's all that's so exciting about it. But it's just this no compromise thing, you know. They don't want to sell them in big numbers. They only have to sell them to the, you know, the people who really know. And that's what's nice about it.
It's very nice to have the same bike as your friend. They are very similar, but they're not the same. Mine's got a slightly different engine, and we swap and we compare. And it's a sort of a boyish thing to do, you know, to ride around together. It's got this awesome performance, but although I don't use it, I know it's there. And it's like, I suppose it's a sort of feeling that you could have if, maybe misers have that feeling when they've got lots of money, and they never spend it, but they know it's there.
Richard Rackham and Julian Thompson were to become key players in the new car project, codenamed M111.
The actual link between the M111 project and the bike was something which we could immediately see what was desired from the car. And it was very, oh, this wants to be just like a Ducati, which is a bit of a toy, you know, a rich boy's toy.
And just something that you just love having and love owning. That's what's important, something like that. The quality we'd like to have in a car. That's why we sort of start with this project.
Lotus was founded by Colin Chapman, who was a very clever engineer and, above all else, I think, a very competitive man in everything he did. During the 1960s, Lotus was perhaps one of the most famous of racing car manufacturers, and this was the period in which Lotus's racing heritage was largely formed. And one of the cars that contributed very largely to this was a car called the Lotus 23. And what this car achieved was to take on the might of the established sports car racers from Ferrari and the major continental manufacturers, and to really leave them for dead.
A decade later, in a bid to improve the company's profitability, Colin Chapman took Lotus up market and launched the Esprit. Over the last 20 years, it's developed into a powerful, sophisticated, and with a price tag of up to £60,000, an expensive member of the supercar community.
In the 1980s, Lotus wanted to add to our product range, in addition to the Esprit, by presenting a smaller two-seater sports car. We identified a very substantial market for this car, and in order to equip ourselves to meet this demand, we invested a large amount of money in the engineering program and, in fact, in the production process.
The Elan, in fact, was quite a successful car in terms of sales and market reception to that, but it really cost too much to make and turned out to be quite a complex car, and the market that we're aiming it for, we either had to charge a lot more money for it or the volumes would just go down to be so small that it wouldn't be viable to do.
The Elan had to fight in a market which was flooded with cheaper Japanese sports cars. It became clear to Lotus that they would never recoup their investment in the Elan, and in June 1992 made the decision to stop production, which meant the loss of 300 jobs at its factory near Norwich.
Lotus was really founded on making lightweight, simple, efficient cars. And a lot of our customers were coming back and say, yep, the cars you make now are fine, they're okay, but what's happened to those original cars? We think there's still an opportunity to have those. We would like to buy such a car. We'd like to buy something that we can go and drive on a circuit or do a hill climb or a sprint with, which is not going to cost us too much money, is not too complicated to look after. Is there any possibility to make such a car? So that really did inspire us to go and look to see what we could do.
This is just an old car. If you want a Lotus 7, you buy a Lotus 7.
It does have some really great elements about it, doesn't it? Like virtually no overhangs and that sort of thing, And
yeah,
because it's open-bodied, you just got this like amazing sort of like wheel at every corner.
But you see, so many people have tried to do modern versions of that. You got the Donkvort, the Mirac, cars like that, and they've all taken that and they've all tried to build on it. Lotus themselves, when they did the later version of this car, the Super 7, the update wasn't as good as the original. It's just an icon. It's got to remain the same. And everyone who's tried to do one of those cars, it just
so caricatured essentially, aren't they?
Yeah. I think the philosophy is what we're trying to capture. And I don't think the look of the car is what Lotus stands for anymore. We are a modern design house, and we're trying to do something which is state of the art.
It needs to have sort of like a hard-edged, no compromise sort of attitude to it, which is what the 7 is all about, isn't it? People who drive 7s are like a bit of a breed apart because it's not your everyday car.
The advantage we've got rather than the disadvantage is that we only have to make so many hundred or just a couple of thousand cars, and so we're only looking for this really specialised customer, same customer who buys a really nice watch or a motorbike or something like that. So we can cater just for this really cool bloke, for want of a better term. And we don't have to cater for housewives and whatever like that, and that's our advantage rather than disadvantage.
Yeah.
So our limited production numbers, we want to turn that round so we can actually produce something really special.
While the designers were discussing how the new car should look, others were in no doubt about how it should feel to drive. The ride and handling characteristics of Lotus cars are legendary, and they're determined by development engineers like Dave Minter, who here is driving an Elan on the Lotus test track.
When we start to develop a new vehicle, it's really up to us as ride and handling engineers to be able to give it the characteristics and the flavour of the car that we want. So we've got quite a responsible job really, in that we can dictate how the car is going to behave. And I suppose it's a little bit of a black art, because we can nowadays, in the 1990s, we can do a lot of objective tests, and we can measure the rate of roll, we can measure this, we can measure that. But in the end of the day, it really comes down to the driver, the subjective evaluation of the driver. It's also very important the feel of the gear change. You have to feel as if it's rewarding to change gear. Otherwise, you might as well be driving an automatic vehicle. And that's not really what sports cars are associated with. This is 90 miles an hour around a long bend, and the car remains very neutral all the way through. And that's a characteristic with the vehicle that we will want to keep in the new M111. The M111 is going to be a bit different. It's going to be a bit more of a dynamic car. So the car will be slightly harder than this. We can do much experimenting with the springs, with the dampers, and on a project like this, we'll probably change the inside of the dampers, the actual valving inside the dampers. We'll probably change that 40, 50, perhaps times before we get the ideal setting that we want. And probably more than anything else, the tyre. And the tyre makes a huge contribution to the ride and handling and the dynamics of the vehicle. So we can change all these things, and it's our job to sift through all these variables to come up with a specification which is fun for the owner to drive.
Something that's been focused upon a lot in particularly the last 5 years is emissions, and particularly greenhouse gases. And one of the major contributions to that is using fuel. If you use more fuel, you're going to create more of these type of gases. So an obvious way out of that is to go to a very fuel-efficient car. And again, the way to do that is to make a very lightweight car, because it means that you can make a car with very high performance, but with a low-powered, fuel-efficient engine.
All high-volume motor manufacturers are under pressure to develop lightweight, fuel-efficient vehicles. But it'll call for a radical change in the way they build their cars. There's a confidence gap. The big car companies are almost too big to gamble on going into production with revolutionary lightweight technologies which might not work. But Lotus felt it could, and early on in the M111 project, the Rover Group became involved in discussions, keen to support and encourage the Lotus engineers.
The targets and the risks, I think it's very important, particularly for our engineering clients, they understand the risks we're taking with a project such as this.
But after being taken over by BMW, Rover pulled back from the project, leaving Lotus on their own.
I think it's always helpful to have a sort of big brother overlooking you, but on the other hand, we are used to running our own type of business and quite sort of flexibly. So I don't think we felt particularly vulnerable.
We had a situation where the board of directors of Lotus could see that we had a vision of a product which could be very successful, that they had a group of engineers who were not only capable of achieving the program and doing it very efficiently, but would be driven by enthusiasm to make the car as exciting as they possibly could, but also that the idea of performance through lightweight and demonstrating new technologies would be relevant to the whole of the motor industry.
In January of 1994, the board of Lotus Cars gave the go-ahead for Project M111. Many staff at Lotus had a vision of what the M111 should be, but it was the head of the styling team who was asked to flesh out the basic concept. Julian Thompson.
I guess all young boys are interested in cars. You know, they always start playing with them and they'll start drawing them. You know, certainly all my nephews and all the young kids I know are always interested in cars. It's one of the things boys do. And most of them grow out of it, and some of them don't. And I think that's where a lot of car designers come from, basically. And I just kept drawing cars for some reason. I don't know why, just liked them. And my memories of my parents having cars were that we used to have a Bedford van and a Mini, and we just used to trade these in for another Bedford van and a Mini for years and years and years, and we never had anything cool at all. We had a friend of ours who came around a Consul GT, and it was like the coolest thing that had ever been in our driveway. My mother's from Thailand, and we have distant links into the royal family. We are related to the king who was illustrious in The King and I, that one. I think he's like great-great-grandfather or something like that. But we get treated pretty well in Thailand, as to be said. My office does a split of roughly 50% Lotus work and outside consultancy work for various manufacturers around the world. But obviously the stuff myself and my designers like doing is doing Lotuses. You know, we love doing that because it's very, very close to our hearts. The company has been in its ups and downs, but I think a lot of my team would stay there waiting for the chance to do the new Lotus. Any project like this, we start with sketches and ideas. You know, you can't stop my designers doing this sort of thing. But what was unusual in this project is that we didn't really start with an engineering package from engineering and sort of like decorate it, for want of a better term. We actually started with a plank of wood on the floor and a seat. And so we started this very, very early, but very, very basic terms. We just got a steering wheel and gear lever in position, and we built up a fake windscreen and a surround. And, you know, we said, is this fun? Does this need to be lower? Does this need to be higher? So we could get some idea about what it was going to be like to look out of this thing. And we were very keen to establish an exciting driving environment. You know, there were so many questions about getting into the car, how the occupants were, how the windscreen should be, all to just have this great sense of occasion.
There are over 1,000 engineers at Lotus, and there's over 1,000 ideas about what the M111 should be. And I think the first task, or the most difficult task, was actually to get everybody to agree on a common direction. So the first phase of that really was to decide what it was going to be, and it almost went without saying it should be an open sports car, and there was very little debate over that. The position of the engine, we had some debate, but I think that was quite easily resolved. We did look at a front engine rear-wheel drive, as with the Lotus 7, but very soon we felt that the mid-engine configuration made more sense for several reasons. First of all, it's very much easier to develop the crash structure on the front of the car when you don't have an engine in the way. Secondly, Formula One cars all run with mid-engines for very good reason. The dynamics of the car are more exciting and more interesting, and I think from a marketing standpoint, a mid-engine car is more acceptable.
This is very much more of a Lotus 7 inspired vehicle, right? But with a much more modern direction there, more integration to the wings, etc. But still picking on a sort of race car theme. What I've tried to do here is create a much more integrated design though, so we're actually blending the body into the rear wheel arches. My own concern about this is perhaps it's a bit too much of a caricature of a Lotus 7.
Yeah, it's one of those things, I mean, if you want a Lotus 7, you buy a Lotus 7. It's not really bringing the game forward at all, is it?
So I've then moved through here, and I'm looking at cars which hark back to some extent to Lotuses of the past. There's lots of classic Lotus design cues on here, the mouth, etc., which you see on the Elan and the Lotus 23, etc. My only concern with this is we have a very, very broken line here because of the cut-down doors, and I think that people would lack a certain amount of security inside the vehicle. But most importantly, we're losing the strength of the line through the car here.
Now, yours are a lot more retro, Andy, if I can say that.
Yes, I mean, you can see, I think, some of the themes that I've tried to pick out here are these things we've been talking about where it's a bit like a motorbike for the road. This one again here is sort of like looking at a simple, almost a get you home soft top roof. It's just something that you scrunch up in a bag and throw in the boot, and if it looks like it's going to pour, you can put it over the top of the roof to get you home.
The M111 was conceived as a step-in car, a car with no doors. But inspired by cars like this 1950s Mercedes, the design team argued for distinctive gull-wing doors. Project manager Tony Shute feared they were too complex.
I mean, the gull wing, I think, technically is very nice. Everybody likes the idea, but I think, in a way, it's down to Chris, because if we can't do it, you know, we haven't got much time to do such a system. If we're not confident day one that we can make it work, so it doesn't leak, it doesn't wind noise, etc., then we really have got to consider whether we can pursue that route anymore.
Yeah, I think the loop you're going round is if you glaze it with Perspex, which is sort of the proposal that's come from sort of Andy and people in styling. We're not sure about forming something that size accurately, and I don't think it'll be stiff enough as a panel, so we'll be able to mould a composite inner to the section, which is going to add weight. Also, you'd really need to support it with a strut. So you're into a mechanical strut or a small gas strut. Yeah. And then you're going to go through the ceiling loop. You need gutters around all the edges to get adequate drainage.
Let's not forget that a conventional door, conventional soft top, as far as the customer's concerned, isn't that attractive when compared. You can put it against a gull wing. Yeah. I mean, it makes it twice the car.
It's very visually exciting, isn't it, the gull wing, you know, and in certain applications as well, it makes entry and exit much easier.
if we look at this program, it's incredibly ambitious anyway. I think we've got to decide whether we're going to achieve it or not. And if we can't all buy into it now, then I don't think we should do it. Not job one, anyway. But I think we should give it another 4 weeks. What I suggest, if you go back and have a look at the window system to see if you can come up with an idea on that, and also stowage of the system, and then we'll decide in 4 weeks.
4 weeks later, the idea of gull-wing doors was dropped. The whole of the Lotus Group has a stake in the future of the M111. Not just Lotus Cars, but Lotus Engineering, a highly successful consultancy company which supplies its expertise to motor companies all over the world.
There are these two divisions of Lotus. The Lotus Cars side is about 200 people, and the consultancy business, the engineering company, is about 1,000 people. And the turnover of each company is about the same. And the way in which this project has been financed is by me stealing the research budget from engineering for 2 years, which of course they want something back in return. And that is really a demonstrator that we as an engineering consultancy company are capable of producing a technically interesting motor car. Very early on in the M111 project, we realized that there were areas of expertise which we hadn't got within the company. So we needed a series of what we call collaborative partners who would come into this project and provide us with the expertise that we need.
Lotus wanted to use lightweight aluminium to build the chassis for the M111, so formed links with Hydro Aluminium in Denmark. The company is part of the Norsk Hydro Group and has been involved in the production of aluminium, mostly for the construction industry, for over 30 years. Recently, Hydro set up a new division, Automotive Structures, a new part of the company to specialise in developing and manufacturing lightweight components for the automotive industry. Components are formed by taking billets of aluminium, like these, heating them to make them soft, then squeezing them through a complex die to form extrusions.
An extrusion is something that most of us would understand if we thought about a tube of toothpaste. When we squeeze toothpaste, we extrude a solid cylinder of paste out. If there was a little ball on the exit nozzle of the toothpaste, when you squeeze the toothpaste, you squeeze a tube out. You see this sort of thing in the kitchen with macaroni, a pasta machine. All this is taking a big blob of pasta and it's squeezing it through a die and it comes out of shape. An extrusion is that. We take a billet of aluminium, push it through a die and it comes out shape. And if you want cavities in it, you put these sort of ball shapes in the way so the material has to squeeze around them and you get the cavity. It's squeezed out in lengths, they can be continuous lengths of 20 meters or so. It's produced at an alarming rate. And on the 111, one squeeze, which takes about a minute, will last several years' production for some of the small components, not on the chassis, but individual components. It's really a material cost you pay for. You don't pay for this great form, you just pay for the weight of material because the process is so quick.
Once Richard Rackham had understood the potential of complex extrusions like these, he began to design his own for the chassis of the M111. His colleagues were surprised by this completely new approach to building a car.
What on earth's going on making a car structure out of greenhouse parts? That's what most people see, or double glazing. That's why greenhouses and double glazing are made of. extrusions because they're incredibly adaptable, and used in the correct way, they say a different set of advantages can be brought into a car structure. This is the level of sketch that we get to before we go to full size. But it's full of lies, so we have to go to full size, understand how an occupant will interface with these ideas. The occupant, Agent Orange, is shown here. Everything about him centers around the hip point, which is there. Agent Orange, as we call him, is a result of wartime American research into how big they should make the cockpits of aeroplanes. This is Mr. 95th percentile. That means 95% of the population would be comfortable inside this car. The unfortunate thing is, in 1945 or 1950, people were a lot smaller. So we've allowed 2 clicks more rearward travel on the seat and a little bit more headroom. The great thing about using tapes in this drawing is that you can just rip them off. It's, if we change our mind about where this side duct should go, and this is a styling function, they can sort of do that and then reposition it quite simply. And it's very easy to visualize. It's not as hard as a pencil. You see there are pencil lines on here, but they're all very soft, and that's where we're using the 2 mediums, but it's like we know you can use colour to your advantage. Like blue means chassis, orange means occupant, and we put various other sort of colours in there. So when you're working just with the chassis, you can see where all the relevant lines are. And the thickness of the line as well. Just like with pencil, you'll push a little bit harder when you mean it. We put the line in here for the ground. We really mean the ground is there, and we really mean the tyres there. And the outside shape is there. But we've got a little sketch in there, maybe we're not thinking about it, and when we put a thin line on there, it's a good way of expression.
Soon after the basic building blocks of the chassis were laid out on the tape drawing, their details were fed into a computer-aided design package, and a 3-dimensional model began to take shape. This incredibly accurate tool would become the reference point for the scores of engineers working on the project, and in the absence of a real car, the arbiter in many a dispute about who could put which component where. But Lotus were not the only company working on a lightweight aluminium chassis for a sports car. Renault were also working on one for the Sport Spider, also with hydroaluminium in Denmark. The Renault chassis is welded together. Lotus believed they could use much thinner extrusions and therefore save even more weight if they glued or bonded theirs together.
Now, the engineering company wanted us to bond because that's what our customers are interested in. We also had an expert employed who told us we should weld, which also encouraged us to go down the bonded route. And I think that's quite important. And to actually meet the cost and the weight targets that we have for the frame, we couldn't seem to achieve that through a welded structure.
Lotus then needed expertise on glue. After talking to several adhesive manufacturers, they found a second strategic partner in Seba Polymers at Duxford in Cambridgeshire.
Going back to the early days, this was when Norman de Bruni started this company. He was a Cambridge University don, and he was very interested in flying, wanted to build his own aeroplane. Aeroplanes in those days were built using wood and canvas, and the glues that were used to bond them were milk-derived, and they were subject to fungal attack under moist conditions. And Norman de Bruni very wisely saw that an adhesive would be useful which didn't degrade under those conditions. He thus developed the urea formaldehyde adhesives. From there, this company got involved in many, many aircraft structures. Car industry has some different requirements to the aircraft industry. In the aircraft industry, most of the metal being bonded now is large area, so the adhesive doesn't have such a concentrated stress. Also, believe it or not, in the aircraft industry, you don't really need very much in the way of impact resistance. If a plane goes into a hillside, I don't think any amount of adhesive would help very much. The car has to resist normal running and also any crash loads that are imposed on it. And so we had to build an adhesive which would be high strength, withstand the weight of the engine and other loads in it, the passengers, but also be resistant to impact loads during crashes. Now normally you'd think of a high strength adhesive, I would guess, as being something that withstands the high loads but is quite hard and easily shattered. What we've managed to do is combine that with the properties of a rubber, which of course under impact is very resistant and doesn't shatter. So you've got those two properties combined in one adhesive. In the past that hasn't been possible.
The adhesive was a breakthrough, but many questions remained about the bonding process. Sieber, Lotus and Hydro pooled resources to research the key issues, how to treat the aluminium surfaces for bonding, and how and in what conditions the glue should be applied. Throughout this period, Lotus always had a fallback position, a design for a slightly different chassis which could have been welded. At the Lotus workshops at Hethel near Norwich, engineers began testing the first of the bonded aluminium joints and used a simple rig to compare them with joints that had been welded.
With the dynamic testing, we're dropping a weight of 15.7 kilograms, just free fall, over a height of around about 2 meters. This test here is one of the dynamic tests that we did. The main problem with using adhesives is peel stresses, which you get in our case in this corner here as we're applying the loads here. In order to alleviate this problem, we've added mechanical fastenings as close as we can to the corners of the joint. Basically, if we can put a rivet in, as soon as the adhesive starts to peel away and hits where the rivet is, the peel stress will stop. So therefore we shouldn't have as much destruction of the bond area. If we compare this to an actual welded joint, which we have here, this had again the same energy put into it. As we can see, we've got a lot of buckling of this member here, and also quite a lot of buckling here.
Under these experimental conditions, the bonded joints, which included rivets to stop peel stresses, were proving stronger than the joints which had been welded. So the prospect of a bonded aluminium chassis looked promising. However, the legal department was about to drop a bombshell which would result in a redesign and a headache which would cost the project hundreds of thousands of pounds.
We've got to the stage now. The basic concept of the car was a stepping vehicle without doors. Right. And I mean, it's a bit of a problem to us. We've now pointed out there is a regulation whereby, with the design that we have at present, we don't meet legal requirements in terms of step over height. And I think it's important that Starling understand this in some detail, because it's going to change the project quite dramatically if we're now going to go away from a doorless car and go to a car with doors.
Well, if the entry area to the vehicle is more than 750 millimetres from the ground, then you have to have running boards.
Now, when you say running boards, you mean some sort of step area designed into the side of the car,
like a Land Rover,
or something like that. Yeah, you've got
designed in, are they?
You've got to drop that
on the side.
You really got to drop the top of the door area down, probably 30 millimetres.
Well, I mean, with the concept that we're running with at the moment, I mean, that's basically completely, unacceptable. We're very keen to keep, the flowing line that we're developing through there, and we certainly don't want to have anything where you actually sort of like effectively got cutaway sort of door holes, which does will make the vehicle look very sort of beach buggy-ish or sort of open jeepish from a visual point of view, and there's no way we would accept that.
Well, it's pretty basic.
Well, I guess it is from your point of view. I mean, it's there. We have to meet that regulation.
No, but I mean, it's going to mean quite a major carve up to the whole concept of the car.
Yeah, but we're possibly only talking about coming down 30 millimetres. That doesn't seem to me to be very much.
I guess, I mean, where we're coming from is that we would much prefer to keep the visual line of the car that we're developing, and have some sort of system whereby you can open a door as well, just to aid, access into the car.
You're talking about a lot of engineering effort.
Yeah.
You know, traditionally at Lotus, you know, doors aren't easy. Next we'll be into sort of wind-up windows and things like that, and door locks, and it's a whole new bunch of regulations that we have to meet as soon as we get into door locks.
How much does a door cost?
What, the engineering cost?
Yeah.
I think given the choice between doing a door and a new engine, I think I'd choose the new engine.
The need to develop doors would eventually cost the project nearly £500,000. The next bombshell from the owners of Lotus landed in the design office.
Suddenly I had this threat of maybe this car was going to not be designed at Hethel. It was going to be designed by one of our competitors. And because we didn't know Bugatti very well, because they're Italian and because they'd asked lots of other Italian design houses, we were very, very worried about losing it. And personally, I hated that time. I mean, there was an excitement of doing this car, but having this threat of it being taken away from us was horrible. A packing crate, 1 metre square, arrived with proposals from 8 other design houses. I had to stick these up in my office alongside our designs, and you know, we won basically, and that was very satisfying. I could have done without it though, for sure. Once we completed the initial sketch phase, we were very keen to get into the next area, which is three-dimensional scale models. The sketches can only tell you so much. They can give you a character of the car, but you can't really understand the shape till you get to this stage. From this model, we identified that perhaps this was a little low overall height-wise, that this sill was probably too high to step over, and I think the model is just a little bit too short to package what we wanted to do into it. So we moved on to the next stage, which is the green car. The green car addresses a lot of the problems we had in the silver car and also moves the styling on the next phase. We're always progressing it and looking at it. So this model is getting much closer to the real car, which allowed us to go on to the next stage, which is a full-size model.
When we first sent the full-size clay to go and be machined, the company that did this for us at a very competitive price had never machined a clay before. And it made such a mess in their workshop that they vowed never ever to do it again. But it was fascinating watching this blob of clay just being turned into a 111. It's quite a fascinating sight.
We prefer not to do at Lotus a lot of detail development on the scale model. We prefer to get a full size. So we would have digitally scanned the scale model, measured it all over, and then got a computer to make a full-size image and machine a block of clay. It's not a solid block of clay. It's got about a 30mm skin on a foam and wood armature. The problems you always have when you go from a scale model up to a full size is that there are scaling problems. You know, if you look at a car on a table and it's just big, inevitably when it gets to a proper size and you're walking around a car park, it's not going to be exactly the same. A good example of that is when people like Corgi or something make a scale model of a car, they exaggerate certain features on it, just so it looks right. The clay we use isn't actually like potter's clay. It's more like a wax, in that it comes out of an oven hot. It's a bit like melted chocolate at that point. You actually, the moment it sets, it's like hard chocolate.
While the full-scale clay was emerging, a third-scale model of the M111 had been taken to a wind tunnel for aerodynamic testing at the Motor Industry Research Association.
In its crudest form, the wind tunnel is a large working section where air is drawn through the tunnel past the actual model. You have a belt, a large rubber belt rotating underneath the model, representing a moving ground, so that's moving at the same speed as the wind. And we replicate the way that the car moves in the wind relative to the ground in real life. Within the wind tunnel model, we have a balance. It's a glorified pair of bathroom scales, basically. It measures the forces in 3 directions. It measures it in the longitudinal sense, measuring the aerodynamic drag, the vertical sense, the aerodynamic lift, and the horizontal transverse sense, the aerodynamic side force. There's often no substitute for literally seeing what's going on, so we'll use smoke stream. It's a vaporized paraffin oil that's pumped through a heated lance, and that physically visualizes the airflow as it moves over the car. Fundamentally, we knew we were going to have problems aerodynamically with the car right from the word go. The physical proportions of the car meant we were going to have problems, and the initial design concept was one which was very striking from a visual point of view, but I knew it was going to cause me some problems. It was very short, very stubby, very fat and very low. That inherently usually means high drag. It's not going to be an ultra sleek, ultra low drag car.
The initial results were not desperately good, and there was some suggestion that it was about aerodynamic as a brick. This is kind of unfortunate because the car had a real style to it, and whatever happened, we didn't want to lose that look of the vehicle.
The aerodynamicist did a spot of restyling in the wind tunnel, mainly to combat rear lift, then broke the news to designer Julian Thompson.
Yeah, I mean, what I'm worried about is that you've destroyed certain aspects of the car completely.
Yeah, sure. I mean,
the back-end design is just completely
But
thrown away.
this is taken like to the finest level, isn't it? We built it up
Yeah.
as we went along and tested.
What you see here is within the proportions of the car, we've just taken the various features and the various lines to the ultimate limit, if you like.
Anybody can design a car, and if you just leave it there, then that's the easy part done. To actually go and make it work, that's the skillful bit. And the trick is to decide what has to be done and what is an optional part to be done, and then get on and do it.
You know, this is so fundamental to the character of the car.
I
Change the whole thing.
But we've got to look at ways of trying to kill some of this rear lift. Now, this is just one way of doing it. It's a fairly extreme way, and there are probably more subtle ways, and we can explore those. You know, but fundamentally, you need to look for some kind of visual form which allows for this trailing edge to come back, up, and make it sharper.
Because this really drops us in now, isn't it? We've had this model approved by our management, and now we're going to come back and say, well, actually, we have to do it all differently now.
One of the problems is that we've got a very high roll bar in this car compared to the length of the car. It is a very short, stubby car.
I know the reasons for it. I just don't know how we're going to make this work. Have you got any ideas? Because the back end was one of the nicest bits of the car, and it's gone now.
There's two ways you could do it, isn't there? I mean, you could actually build a spoiler.
We can't have a spoiler. We won't have a car like this wouldn't have a spoiler. We can't have a spoiler.
I'm sure we could have some kind of integral feature, not necessarily a standalone spoiler like on the Esprit, but a built-in feature to the car which basically just sharpens up this edge.
As the discussion on restyling continued, the first prototype chassis arrived at Lotus from Denmark.
When the first chassis arrived at Lotus, obviously that was a key point in the design program, and it was quite exciting as the box arrived and it got lifted out and put on display, and then everybody's reaction to it was like something that had come from another planet, because it's a very aesthetically nice piece. Aluminium is a very nice material to look at and touch, and it was a very simple chassis which people, I think, could relate to.
A lot of people thought it looked weird because there was nothing seen like it before. There were a lot of people walking around banging it, and listening to the sound of the drum. I think that was probably the biggest criticism. But for every one of those, I think there were probably 100 who looked at it and thought, this looks really space age, this is where we should be going.
For the next 4 weeks, technicians worked around the clock trying to get the first chassis running before the Christmas break. On Christmas Eve, they were still at it.
Yeah, we're desperately keen to drive the car before Christmas, and everybody had been working many, many hours, and it would have been very disheartening to go away for the Christmas break and not knowing what it was like. And there seemed to be, at 6 o'clock in the evening, about 50 items that still needed to be done. Looked like an impossible task, but the question was there anything we couldn't do by midnight? And nobody could come up with anything we couldn't do, so therefore, by logic, we should be able to do it.
The excitement had been building through the day. Lots of people were guessing how much it's going to weigh. We had a little sweepstake going. There was the enthusiasm of the technicians, some I'd never known anything like it. We were all getting stuck in. We just wanted this thing to roll. And at the time, we even thought it didn't look half bad because, you know, love is blind. Looking at the Proto 1 now, it looks hideous.
Hello, Christmas, Richard. I'll see you next year. Yes. Yeah, definitely. It's like that car. Yeah.
When it was time to drive, we fired the thing up. I put our crash helmets on and went out onto the test track. It's icy. It's a brilliant moonlit night. It was quite, well, it was really, you know, one of those magic moments.
The first impressions of the car were really quite amazing because the car was very, very quick. The engine, the torque and the lack of weight, the thing was just so dramatic that it was quite a surprise. Also the steering response and items like that on a first-off prototype were just something I say I've almost not experienced before. And I remember as we were coming around the main straight of the circuit at Lotus, I started to get wet, and I thought we were really lucky because had we been 5 minutes later, we'd have not been able to go out because it had been pouring with rain. What I hadn't realised was it was a heater pipe that had come off and I was getting covered in antifreeze, which at least was keeping me warm, if nothing else. So it was a great moment. We got the car back to the workshop, all then disappeared off down to have a few beers in the pub. We also realised we got an awful lot of work to do the following year. There was a lot of development, a lot of durability testing, just a massive, massive task. So we went away happy for Christmas, but we realised that it was going to be a tough year to come.
In the new year, Proto 1 was taken to Millbrook, a top security vehicle proving ground in Bedfordshire, to be tested to destruction. The big concern was over the aluminium chassis and the revolutionary way it had been glued or bonded together. Laboratory tests suggested bonding was stronger than welding, but would the bonded chassis survive years of battering on real roads? The Millbrook test circuits are designed to find out.
The big test for a bonded structure, or for any structure, is for it to complete what is known as the Belgian Parbe test. That's 1,000 miles of extreme testing of severe surfaces. It's like the worst road you can go over.
It's called Parbe from Belgian Parbe when the roads were traditionally made out of cobblestones, and it just vibrates the car to death. And if a vehicle can survive that without any structural problems, it's done quite well.
But you run around at 30 miles per hour. You can only do that for about a 15-minute stretch, and then you have to have a rest. It just shakes you about so much.
The main reasons that we use Millbrook is they have correlated data, so they know what happens with the cars being in normal service, say for 10 years or for 20 years, compared to their accelerated tests that they do within the proving ground. We use the Millbrook engineers to do the work, we don't do it ourselves. The car is going through a controlled process, and therefore the data that comes back is really meaningful, so we can react to it and not start changing things unnecessarily, and which is just as important as making changes to make sure the car is durable. I think the thing that's really encouraging to everybody who's been in the car is the ride comfort and the feel of a really solid structure. And it's obviously going to be a very nice platform from which to develop the ride and handling on the vehicle. Even over the Parve, with these extreme inputs, there is really no sort of squeaking or rattling in the car, and it feels absolutely solid.
You put any car on there, it's going to fall apart to a certain extent. Our first bonded chassis went round, and there weren't any failures on the bonded chassis, because we knew that if the chassis had been welded, it would have had failure. The great thing about a bond is the stress distribution in the joint. It's a huge area to take all the the loads going in, whereas a weld is a very fine line trying to do just as much work. So at that point, it was a brain-out decision. Bonding was in.
The main chassis structure continued to prove immensely strong, but 3/4 of the way through the Pave testing, cracks began to appear in the rear subframe, which had also been made of aluminium.
I'm not happy with the way that the using an aluminium rear subframe. It's just the loads going in. It doesn't want to be made from aluminium. You know, I feel like we're doing it because the rest of their cars are made of extrusions.
It's mega expensive as well, isn't it? It's not.
It doesn't lend. You know, the rest of the structure is quite elegant, but to use an aluminium rear subframe bonded together isn't a direction I'm happy with. Another problem, which we haven't really thought about, or I've only just realised, is that the catalyst, we're testing now in the middle of winter, 30 miles an hour around Pave. You know, if you put that into the middle of an Italian summer with a much more enclosed rear end than what we've got, the catalyst temperature is going to be going into that rear subframe. And the adhesive is good for 200 degrees C. The catalyst is run at 600. There's going to be lots and lots of heat insulation in there. And we've got to come up with a way of making it from steel which doesn't distort. You know, we want 0.5 millimeter dimensional accuracy on all the hard points.
And it's not easy either, because the transverse engine, it's difficult to get around, isn't it?
Yeah, it's terrible.
This reinforcement has had to be put on to really hold the thing together.
Yeah, I think
there's some serious cracks here.
Well, given the time available, I think I'd prefer to go to a steel one straight away, because we know we can make it work, we can make them in-house, and the problem will go away.
In styling, there was a problem which wouldn't go away. The full-size clay model, which would be the master template for all the M111's body panels, had arrived at the design studio. A team of model makers had begun the intricate task of shaping its surfaces by hand. This is how the head of design, Julian Thompson, intended the car to look, with simple flowing lines. But wind tunnel tests on a third-scale model had shown that Julian Thompson's original design gave the car too much rear lift. The aerodynamicists feared that in such a light car, it could cause instability. So the design had to be changed.
So we had to add on this spoiler on the back, which we did agonise over a lot, because it did take away some of the purity of the car. But it did add some originality, and it did add some aggression. So now I don't have a problem with it, really. I quite like it, actually. The reason we use clay and we don't use wood or foam and anything like that is because the whole process of developing the model means changing it a lot. We employ model makers to not just build the model once, but to keep changing it to our instructions, to keep taking away and trying different things in 3 dimensions. So a good model maker has to have a lot of patience with his designers. He has to be prepared to make something beautifully and then have a designer say, no, I don't like it, do something else.
After the redesign, prototype 2, fitted with handmade body panels, was taken to a full-size wind tunnel.
We came to a nice compromise in the middle between the styling and the aerodynamics, and the designers were happy with what they were seeing visually. When we got to the full-scale prototype stage in the wind tunnel, we were looking a little bit more detail. At that stage, we found that we had got, not surprisingly, a compromised result, a compromised performance between the one extreme that I developed at model scale and the initial starting point of the designers. Because by the time we got to this full-scale test and development stage, we found that the car felt very good. There was pretty much just that right amount of turbulence in the car, just the right amount of wind in the hair. It was pretty good. There was a little bit of tweaking to be done on the rear buttresses. They had to be brought inboard a little bit because a little bit too much air was diving inboard of those. But it was pretty close to what we'd intended for the car at that stage.
Once the styling of the M111 had been signed off, it was then over to the manufacturing team to put the panels into production. 20 years ago, Lotus invented VARI, vacuum-assisted resin injection, a process of mechanised moulding where sheets of fiberglass are sandwiched between 2 moulds and resin is injected between them at high pressure. The process is accurate, produces a consistently high-quality panel, and has low labour costs. This is a Vary mould for an inner panel on the M111. The network of piping ensures equal distribution of heat during the curing process. But it soon became obvious that the complex curves and swooping shapes of the M111's outer panels could not be made with Vary.
The preferred option within the company now is Vary. One of the things that Julian wanted was a fairly evocative style. Wasn't really suited to manufacture using our Vary system. We've been using that system since the Elite. It's a very low labour intensive system, gives a good quality of panel, but a lot of the features Julian wanted around the headlights, on the rear of the car, the rear spoiler, rear lamp area, didn't lend itself to using Vary. Styling as usual, and Julian Thompson will hate me for saying it again, but they always do try and push the edge of the, right to the edge of the envelope. They always want the lights in almost an illegal position. They always produce shapes which the body process people hate because it compromises their process.
The body panels team had no alternative but to build the complex sectional moulds, which are used in the more labour-intensive and therefore more expensive hand-lay process.
With the hand lay tool being in sections, although it does allow us to produce these complex shapes, it does give us a problem, as every time those sections are removed, there is a chance of damage to the joints between the sections, which leads to repairs in the paint shop of the finished component and requires that the tool is serviced on a regular basis. The project team has been made up of several people who have not been all the way through a program before. They have brought a certain amount of lateral thinking into the program, and it's been quite frustrating at times to try and explain to them that if they stuck to their original disciplines and perhaps listen to the people who've been through the body processes or the manufacturing processes before in their time at Lotus, that life would be a lot easier.
A few months later, the first set of hand-finished painted body panels were ready for fitting to prototype number 3.
The clay model does give you a very good idea of what the car's going to look like, but it ultimately can't tell you the whole story. You have to see the car and paint, glass in it and everything to get the whole picture. And a much larger car company with a lot more resource, they'd be prepared to make a show car or a running car, and then if they didn't like it, they could go backwards and start again. We didn't have that luxury because of the time frame as much as anything. So we were very committed to this first car we built. And so once it was sort of bolted together by technicians and pushed out into the sunlight, that was it. If you didn't like it, it was sort of tough. Fortunately, we did like it. It was much smaller than I expected. Clay always, because it's a horrible sort of sludge-coloured brown, it always looks much bigger than it actually is and always looks heavier. The car looks a lot more elegant, and certainly the way the surfaces worked and how the light fell on it, it was better than I expected. Very exciting. It was a very good good moment for us.
Computer programs predicted that the M111 would accelerate from 0 to 60 in 5.9 seconds and have a top speed of over 125 miles an hour. Now it was time to develop the performance of the real race car for the road. By summer 1995, the ride and handling engineers were having a strong influence over the M111's development. Here, tyre testing is the excuse for a spin on the Motor Industry Research Association's skid pan.
I'd like to talk about some vehicle weight issues. We're running into increasing problems as the weight of the vehicle is just going up and up and up. And the closer we get into production, we just seem to be adding more bits and more weight. And unfortunately, it's a sort of standard thing. When things go wrong or fail, we end up adding weight during the fix rather than deleting it. The target weight for the car is 650 kilos. We've agreed that when we made the changes going to doors, etc., etc. Currently, we're looking like 703 kilos. So we're 50 kilos overweight, and we need to find some means of getting rid of that weight. So what I'd like to do today is, can we talk about some areas where you think we can save some weight? Have you got any ideas? Is it worth going through the sort of function codes, starting off with glass, body parts?
Yeah, glass windscreen's about the minimum thickness for the size and the shape.
What thickness is it?
It's running 4 mil at the moment, or 5. It's running 5 at the moment.
Right. So what is stopping us downsizing? It's a non-standard, presumably.
Yeah, you're just getting thinner and thinner, and it's hard to form, and you'll get distortions in it.
Right. With the other issues we got on the silent channel and so on, it's not worth looking at 3 mil glass, is it? Rather than downsizing the
I think it'll end up too flexible.
Is it worth looking at it?
It's possible. I think it could be a cost increase.
Okay.
I can't think of anything apart from a hollow gear knob, which is going to make the chassis systems lighter, and that's not likely. As the weight's gone up, if anything, I think we're going to be as the gross vehicle weight has gone up, we're going to end up with having to put extra weight in to compensate, because everything's been designed around the original target, was 575.
Yes.
We're now up to 700. So I expect more weight in the rear subframe.
On the basis that the easiest way to save weight on a car is to look at the heavy bits, the brake discs on the car seem to be a good area to focus our attention.
Lotus began searching for a third strategic partner, this time in the United States, where concerns about emissions and fuel economy are forcing all motor manufacturers to reduce vehicle weight. They joined forces with the Lankside Corporation, a technology company which was developing a revolutionary material for brake discs, a blend of aluminium and ceramics.
This program went together very quickly for an automobile, something like 20 months or something from the conception to first production. So it was a fast-moving program, and that too interested us a lot. We're interested to get our materials into the commercial marketplace as soon as we can, as soon as reasonably practicable, and so that had a lot of appeal to us too.
To ask for a review.
We started to together explore the possibility that perhaps we could put on this vehicle metal matrix or lightweight brake discs on all 4 wheels. And that's very much a first. Some vehicles have been designed where the rear wheels are using MMC materials, but this is the first vehicle that's designed really to employ lightweight brake materials on all 4 wheels. Our materials are lightweight. They have other advantages. They're also very wear resistant, and so Whereas a normal brake disc, brake drum, would be made of iron, the ferrous material, and that material would normally wear over time. The pads would work, the brake pads acting on that material would wear it away. Slowly, but they would wear it away. These materials break in a very different way. The brake pad coats the disc with really a transfer coating, a layer. And the braking action comes from that transfer layer. And once that transfer layer is established, the wear rate of the disc is very, very low. At least conceptually, we could see a disc lasting the life of the car, 100,000 miles. One branch of our technology allows us to make a composite material which, under a certain restricted set of conditions, can be cast, just like steel or iron or aluminum would be cast in a relatively conventional foundry. We made the prototype discs here using a sand casting technique, where we make a sand mold, which is the reverse of the shape we want. Pour into that sand mold composite, molten aluminum containing reinforcement, allow it to harden within the mold, and then breaking the mold open and allowing us to take out the final part.
A second US company became involved in preparing the MMC discs for Lotus. Hydraulics are part of a massive company which supplies brake parts to motor manufacturers and consumers. They also believe that lightweight aluminium components are their future.
There is increased pressure on lighter weight vehicles. There always has been, I believe there always will be into the future. When that next oil crisis comes, whenever that is, there will be a lot of pressure to go to eliminate as much cast iron as possible, and the sprung weight of cast iron products like drums or discs will be a great candidate to reduce that weight.
The metal matrix discs, which may eventually be developed to last the lifetime of a car, are also very difficult to machine. Hydraulics had to invest heavily in diamond tooling just to supply the prototype parts.
We don't look at the program as a program where we're looking to make a lot of money. Quite the contrary, we look at it as an R&D program. We are involved in new technology that many of the other major brake rotor disc manufacturers are not involved in. And the Lotus is one of the first programs that is actually going to market. We, as a very progressive and growing company, wanted to be at the very forefront of that technology and believe that that will be where the growth will be for us in the future in these various niche markets like the Lotus program.
At the Lotus factory in Norwich, the team developing the M111 had grown.
I would like to make that an option if possible, so we can get loads of dosh for it, for the passenger side.
If there was a footrest there, then that would impinge on him. Yeah. That would stick in the back of his legs.
Ride and handling experts were now at project meetings, bringing feedback from the test track. Those who'd be responsible for building the assembly line were also involved, as were those who still had to source nearly 2,000 production parts for the car. The head of design, Julian Thompson, who originally styled the M111, found himself defending his concept now that people with the practical responsibility of putting the car into production were involved.
Well, we've always been underdogs. I mean, there's always been, whenever company go to, there's always been a battle between engineers and stylists, they like to call us. You know. They group us together with hairdressers and the rest of it. engineers approach a problem is very much more mathematical and logistical, and aesthetics doesn't really enter into it for them. I mean, if you see a car an engineer's done on his own, you often see these things they've done, and they're just awful looking. But it doesn't matter to them. I mean, I've often said that the average cleaning lady's got a better sense of aesthetics than an engineer. And it's certainly true. It's very difficult to find engineers who are good engineers, but also have got a good eye for what is aesthetically pleasing. Colin Chapman certainly did. And there are some engineers at Lotus, certainly Richard Rackham, who I work with, does as well.
Rackham, the engineer, was best man at Thompson's wedding.
Our backgrounds are totally different. Julian's background is, of, I understand, Thai royalty, you know, they're from that sort of line. I'm from working class Norfolk background. Our similar backgrounds in that we both had a very moralistic upbringing. For fun, I used to, when I was a kid, I had a Meccano, which was great, set me up for life. Well, this pirate flag used to be on my chimney to help people find my house. It was in the country and no one could ever find it through the house name, so I stuck the flag up there. I'm actually related to a pirate called Calico Jack Rackham. Now, he was actually killed in 1792 by the Royal Navy when they attacked his ship. The Royal Navy found 2 women on board, which is pretty strange for a pirate ship. One died in the battle, or shortly afterwards, I should say. The other one died in. The other one gave birth to a baby when she was in prison. From that baby, I spring. Now, the woman got onto Jack Calico's ship by pretending to be a man, so she was a transvestite. So I spring from a line of transvestites and pirates, and that's not bad, is it? Down here, this is where it all started for me with mechanical things, apart from my Meccano, of course, which I had when I was 5. This is the first engine. This is a Cycle Master, which is used to buy these in the 50s, take the wheel out of your push bike and stick this in instead. Put some number plates on and off you went. I found this when I was 11 or 12 on a bonfire on the beach at California Cliffs in Norfolk. I fixed it up. I remember the petrol tank, there'd been so much heat that the solder joining the tank together had melted, and there was just a big bubble of solder in the back of the tank. So I actually stuck, this is topical, this one is stuck together with Aldite, which my brother gave me. And it hasn't leaked to this day. What have we got? Right, this motorbike is a Sunbeam S7. It's a design classic. This is the sort of motorbike that you saw in the Christmas cracker when you were a little boy. It's got big tyres, it's got great proportion, all the mud guards are really rounded, you know, everything flows into each other. There's unique design features on it. I don't want to go into too much detail, but you've got a cast aluminium silencer, shaft drive, the car-type gearbox and clutch there, 2 cylinders in line, just like an old car engine. You've got a distributor on the back of the overhead camshaft like a car. The generator is right on the crankshaft line. Oh, it's just full of it. I don't know how you're supposed to read the ammeter, though. You have to look under your leg when you're going along. But it was a revolution, really. The guy who designed it, Erland Popp, unfortunately went too far with his single-mindedness, and it cost him his job because this was very expensive to produce. Full of unique features, but they were all so new to the manufacturer, it just couldn't keep up with it. There was too much, too soon. But now it's quite desirable, I think.
I think probably the most difficult period in the whole process was really trying to resolve some issues over windscreen design, which was very, very difficult and caused a lot of grief, to put it bluntly.
The problem was that it was thought that a screen of that shape and curvature couldn't be wiped with a single wiper, because the wiper has to go completely around the corners of the screen. I really wanted there to be a central single wiper. The reason for this is it's the most efficient aerodynamic setup you can have. and it's very cheap, and it looks racy. You know, you look at any old Group C car, you know, there's a single wiper in the middle going like crazy.
We didn't want to have pantograph wipers, we didn't want to have 2 wipers. But there are some very, very heavy legal restrictions on what you have to do. You have to take vision lines from the occupant, they pass through the screen, and a certain percentage of that area that the occupant looks through has to be wiped. If you have a very curved screen and you have a single wiper, it's difficult. But unfortunately, you know, some of our engineers would like to design wiper systems that are designed for any car, and they weren't willing to look at different solutions, and really, it comes down to putting your job on the line a bit to really fight for something.
There was a screen with the plastic screen with all the wiped areas denoted, areas that we had to wipe denoted on it. And I went out one day and put a Citroen AX system on it and declared it could work with a single wiper. What I did is I tilted the wiper motor spindle slightly in relation to the screen, and that's made it possible. But, maybe it was actually holding a wiper motor and having the parts in my hand that made me realise that could happen. I'm sure that other people could have seen that as well, had they had the parts in their hand at the time.
At Millbrook, testing of the heavily disguised prototypes continued in secret, but one motoring journalist, Jeremy Walton, was allowed an exclusive preview of the M111.
Steering is truly delicate, truly like the original Elan. Magnificent. Now this morning this car's been through 20 stops from 105 miles an hour to about 50 miles an hour. So anything I'm going to do is quite lenient on it. You see it'll catch.
So what's the best thing to do, you say?
Well, if this guy will let me, we'll back down to I can't go forward, so if we back down towards a flat section. And it? Come on. That seems to have fixed the problem, David.
Yeah, the engineers tell me that going to Stelvio to do brake testing is essential. I've never been myself, but when I see the photographs, I think maybe the location says it all, really. It's obviously a very nice place to go. It is an industry standard, particularly for driving down hills with caravans and so on the car, where the car's going very slowly and the weight or the trailer or whatever is pushing the car down. You can find you can lose brakes when you get to the bottom. Because we're using new technology, it's very important that we've proven that we've gone to Stelvio and that it will survive all those sort of tests.
One of the big details that I always remember is there's really no runoff area. So if you do misjudge it, you could quite easily end up down the bottom of the valley. And when you're driving down there, you're always mindful, as well as driving as hard as you can, trying to give the brakes as much grief as possible. You're also, in the back of your mind, looking out for any signs that will warn you of a possible failure, because we are talking about prototype parts. It's a very, very harsh environment. the gradient and the twists that you find in this particular location wreak absolute havoc with the brakes. And the idea really is to go as fast as you can and as safely as you can, and using the brakes as much as you can. And then you record all the data, and then you review it, and you find out exactly what's happened to the brakes. Have they overheated? Is there any what we call pad knockback, so that the pad moves away from the disc? Do you find that the fluid boils? And that's something which absolutely astounded us. Other cars that we've taken down there, when we get down to the bottom and the heat from the caliper soaks into the brake fluid, then you start getting a loss of brake pedal. There was none of that at all, because the brakes run at relatively cool temperatures. What we wanted to do was make sure that the system worked, that the brakes were going to be acceptable for this sort of car. So we weren't really concerned about the design that much, but we were concerned about the application. We came back from Stelvio with a very warm feeling for the brakes in its application, because we felt that we proved out that the application worked on the car in its harshest environment.
But the results we found at Stelvio was that the disc runs at a relatively low temperature compared to a cast iron disc, and that really was quite surprising, because the MMC dissipates the heat so quickly that running some of the most arduous brake tests that we carry out in Europe, particularly at the Nürburgring, where typically we'll be getting 600 to 700 degrees centigrade on the Nordschleife circuit. With this particular disc, we only reach about 210 degrees, and that's only just a warm disc basically, and that's got huge advantages in terms of wear. And again, I think it's possible, may not be on the car at the moment, but in the future to make the pad and the disc last for the life of the car, 100,000 miles.
Designer Richard Rackham was discovering the true potential of aluminium extrusions, components made by squeezing heated aluminium through a complex die. He'd used them in the chassis, but found they provided simple, elegant solutions to other design issues on the car.
You don't think about, oh, these two parts will come together, then we'll put a bolt through there and a screw. You think about, can we make these two extrusions hook together and do away with the fixings? You look at individual parts and think, could they be an extrusion? Greatest thing was when I was working on the package, looking at the pedals, trying to fit a Metro pedal box in the car, which looked hideous. It was big, it was heavy. But I thought, hang on a minute, I'd sketched out an ideal pedal shape from the side, and suddenly I saw an extrusion there. And that was great. If I hadn't been tuned into extrusion, it would never have happened. I think the pedal's caught a lot of people's imagination. It's something which everybody can identify with, because whatever you know about cars, you put your foot on a pedal. So that's one reason
The other reason is it's something which is easily held in the hand. It's got a nice curvy shape to it, and it's got a clever sort of pad which goes on. Julian actually wants to turn one into a telephone, and he thinks we should send them off to clients, and that's the Lotus thing. Tony Shute, he's had, you know, dozens of them made up just to give away. I'm really pleased it's taken off like that.
Many of the larger extrusions are made by Hydro Aluminium in Denmark. These are the main side rails for the Lotus chassis. Normally, after being formed, extrusions are cut to length, then cured at high temperature to protect and strengthen the aluminium. But the side rails for the M111 need to be bent, so they can't be cured immediately. And, as there isn't a press in Denmark which is big enough to bend them, they're shipped to England, bent there, then shipped all the way back to Hydro. Lotus became concerned about quality controls and Hydro's lack of progress with the new unit it was setting up to manufacture the M111 chassis. Quality assurance engineer Peter Wainwright was sent to the Danish suppliers.
The result of the first visit was, from our point of view, quite disappointing, in that we'd come to Denmark. We'd found that there's basically an empty shell of a factory, a few offices, very few people, no real control systems, and a company that's got no experience of a job that we want them to do. So over that summer, every time we made a visit, it became more apparent that things, shall we say, in line with a normal timing plan that you have for a project, weren't being achieved.
They set up the automotive structure division a few years ago because they could see that aluminium would become more relevant in the automotive world. Suddenly, they've got two projects which have come to fruition. It's the Lotus project, the bonded structure, and the structure for the Renault Spider, which is a conventional welded structure. In the past, they've had projects which had come to nothing, but suddenly these have both taken off. So suddenly they've had to build a factory. They have to put in place all the people to make the manufacturing process work. And that's something they know nothing about. Must have been a very difficult time for them.
The real problems, I think, became noticeable when they weren't being able to deliver things. And it was starting to threaten the rest of the project.
It was planned to launch the car at the London Motor Fair, and Mr. Artioli, our boss, came along and said he'd like to launch the car at Frankfurt because he wanted a more international forum, which was understandable, which was fine, but it was only 4 weeks before the show. I took him into the workshop and showed him the pile of parts that was the show car, and I was really a bit nervous because you can't half commit yourself to going to a motor show. You either go there or you don't go there. And so we sort of said, well, we'll certainly do our very best. So we had 4 weeks to build a car up to show standard, and we achieved it just. I think choosing the name for the vehicle was taking longer than it was actually designing and developing the car, as always. Traditionally, Lotus cars have begun either with an E, such as Elan, Eclat and vehicles like that, or with a type name. Very close to the launch, Mr. Artioli decided it should be named after his granddaughter, and I think the names actually fitted very, very well, and I think it got received universally in the company. Now people have learnt to pronounce it.
And because the chassis is the key to this vehicle, I should like to ask the team, and in fact, if you could move away a little bit, I should like to ask the team to unveil this chassis display first.
I wanted it to look as good as possible. We had a special chassis put together at Hydro without too much adhesive showing. We had a suspension system chrome plated. I actually designed the stand for it, which was a very lightweight looking thing. You know, the chassis is supported on 3 slender nickel plated rods with tension wires between, like you might find on an aircraft, an old aircraft.
It's the first time to show the car to your peers. You know, the design community in Europe is very, very small, and we all know each other. And when you design a car and it's been sitting in front of your desk for 2 years, you really can't evaluate it. You can't really know what it's about. And so you put a thing like this, and it's sort of really a matter of what do you think. And at that point in time, your own opinions are very, very confused. And so you're listening out for every single little snippet of what people are saying, good and bad, and dissecting everyone minutely and analysing it. Far too much. You shouldn't do that. So it was quite nerve-wracking for me.
Elise.
It's sort of like a little bit of rivalry that really, you know, people looking at the car, how many are looking at the car, how many are looking at the chassis, and I wasn't surprised, but a lot of people were surprised by how much interest there was in the chassis.
As most designers like to think themselves being engineers, they're all coming up and saying, oh yeah, great chassis, sort of, could have done the body better sort of thing. And that was very much, so it was great for Richard, but it wasn't great for me.
What do I think of the car? I think it's a little bit fussier than I expected for something which is said to be a Lotus 7 replacement, but it's nice styling. I'm sure it'll be a success.
Well, I think it's a great concept, because a lot of the cars today have got no distinct personality, but this is very unique looking, plus it seems very affordable.
Strange. It's curiously styled, I think. It's cute. Yes, I want one. How much?
It's why Elise? Because Elise is my big love. That is born when is born this car. Is my granddaughter Elise. So I am Elise, and she is born when is born this car.
The show car at Frankfurt was miles away from a finished car. It looked pretty good, but it's not tested, the durability has not been done. All the body panels had a lot of hand finishing on them, they weren't off production tools. And getting the car from that stage into a production vehicle is very frustrating because the finance people can't see there's any work to do. You know, the car is finished. In reality, when you've got to that stage, a show car, you've probably done 30% of the project. And to actually get all the tools and so on ready to roll so that you can start throwing them out like peas out of a pod is very, very complex and very involved. And there were a lot of issues that still weren't ready to commit the car to production. The amount of work we now had to get from the show car to production was enormous.
Getting into production was to be the most difficult and frustrating stage of the Lotus sports car project. It began with major design changes and delays and ended with a dramatic boardroom battle when the whole future of car production at Lotus seemed under threat. This is the final phase of Project M111. By February 1996, 2 prototypes were pounding the tracks at Millbrook. It's a top-secret proving ground in Bedfordshire where scores of motor manufacturers test new cars to destruction, away from the prying eyes of the press and the public.
We have obviously a lot of experience on testing cars, not only our own product, but other people's product. And we have a very, very wide database of what cars must do if they're going to be successful when they go out to the public. And we know that if a car doesn't meet some of these requirements and we can't sign it off, then we're going to have huge warranty problems. So all our cars go through a very rigorous test, which is not dissimilar to the major manufacturers worldwide. The unfortunate thing about this, with the number of cars we make, the cost of the testing is just the same as for the volume manufacturers. And the detail that we have to go in for each of the parts is just the same.
Millbrook's 300-acre site is torture for new vehicles. It's dominated by a circular 2-mile track for prolonged high-speed testing, an alpine hill route designed to thrash gearboxes and brakes, and on other parts of the track, special road surfaces which mimic the most severe battering a customer could ever give to the suspension and structure of their car.
You build your first prototype and you run it around the yard. It feels wonderful. You run it around the track, it feels even better. You do a few more checks, it's still good. You then send it to Millbrook, they run it for a week and something breaks. The potholes are a severe force that the vehicle has to contend with. As the car approaches the pothole, the tyre will first of all drop with the road surface and the car will start to lower itself, and then you will hit the far end of the pothole, which will punch the tyre and the wheel back into the bodywork. Very sizable bang. I'd rather not tell you how often we do it, because that's part of our technological property, if you like. The durability test documents the deterioration that a car will see over the accelerated type of forces that we put through the car. So Lotus would start off with a fresh vehicle. We would inspect it to make sure we knew its condition at the start of test precisely. We would then start running it to render it as second-hand as we thought necessary, and inspect it all the way through the test so that we had an exact measure of how quickly it was deteriorating. Design engineers might get into the trap of fooling themselves that they haven't got a problem, or that the problem is a proving ground only problem. Eventually, a paying customer will find that problem. That's what durability testing is about.
Back at Lotus, project manager Tony Shute was briefing a team from Rover, engine supplies to the Lotus Elise.
Why the Elise? Basically, we had identified a need to go back to a low-cost Lotus. That's low cost in Lotus terms, not in Ford terms. We wanted a car to go back to basics, a fun car, the sort of car that you'd own to go fiddling with at the weekend, to tinker with. We're looking at something that's a serious toy, not A to B transport. The basic price of the car, we'll be selling this less than £20,000, and yet we're writing off all the engineering investment over just 2,500 cars or thereabouts. True to Lotus heritage, simple. Do we need 4 wheels and tyres? Do we need a spare wheel and tyre? You know, why do you need trim down the side of the car? The structure on the front of the car is a crash structure, but why can't it be a support for the radiator? Why can't it be an aerodynamic wing? Why can't it be where the tow hook goes on? It needs to do many, many things. That way you can eliminate lots of parts, which means you don't have to design them, you don't have to pay for them, and you reduce the weight.
When the Elise was unveiled at the Frankfurt Motor Show in October 1995, it looked as though the super lightweight sports car was ready for production. But it was just a show car, a glossy, hand-built prototype. 4 months later, when the assembly line began to take shape in the Lotus factory, major design issues were still unresolved and hundreds of parts were missing. Technicians were supposed to build 4 prototype cars to learn how and in what sequence they could be put together. But with the design still fluid, it was almost impossible.
Well, 2 weeks ago when we came onto the line, we had very, very few parts. The chassis came in late, so we had to do what we could sub-assembling parts that came in advance. It's very difficult to get any sort of controlled build when you have to build the car out of sequence. The parts supply situation can be quite frustrating when the lads on the line are trying to help out and get the spec of the car together, and we pull the relevant paperwork out, find out what the fixings are, go to great lengths to find the part numbers, and then go to the rack and then find they're not here yet. I think we have a lot of parts missing because the program is very short in terms of car design to production. We've had a few odd hold-ups along the way, as with any program, and the design is still fluid. Keeping pace with the design changes is very, very difficult, and I feel what we should do, and certainly we don't hear, and I don't think many companies do, we should have a real solid design freeze. But in reality this doesn't happen because you get parts that have to be re-released for safety issues, legal reasons, cost issues, suppliers go down the pan. You know, there are 101 reasons why. There's always a reason to change a part, and often it's also used as an excuse to improve the part where we realise that maybe it wasn't 100% in the first place. At the current time I would say we're about 4 weeks late on completing the first car. We're all prepared to work extra time as need be to get the project in. You know, it means everything to us. It's our future.
The manufacturing team were forced to use a lot of slave parts to complete this car for the Geneva Motor Show, dummy or substitute parts which would eventually be replaced with the real thing. Keeping track of nearly 2,000 parts was proving a logistical nightmare.
The most significant part is the 118 with no supplier identified. Yeah. Because those are items that at the moment we're still not sure on. And a lot of those will be new parts coming onto the list where I just have a description, and as yet I can't really follow that up with inquiries. Again, some of those may be deleted at a later date. You know, parts come off the list as fast as they go on at times, but so how significant they are, I don't know.
They're not the difficult bits then?
No, there are some difficult bits. A lot of the door components are in there.
Exactly. They tend to be the difficult bits that are difficult to resolve, don't
The
they?
grills are included in that because we're still working on those. We can't actually order them. There's a few seals and things like that. So.
A few seals.
A few seals. Something simple, like extrusions.
The shortage of parts was beginning to delay car production, and the pressure was mounting for the parts buyers like Dave Smith. He'd sourced some header tanks, but it seemed his suppliers had stopped trading and closed the doors of the factory. Dave called on his network of contacts for help.
Hello, Mike, how you going?
Not so bad, not so bad.
Any news on header tanks?
Header tanks, you've had all the header tanks you were going to get off us.
Is that right?
Well, you had 12, didn't you?
Yeah, you got a problem on supply now, have you?
Well, we always have had, yeah.
Yeah.
You know, we managed to get hold of 12 for you.
Yeah.
From somewhere.
Yeah.
But there was none and is none.
So it's into the rare and rocking horse category, is it?
It is indeed.
Yeah, right. Okay.
I don't know what the state is. I mean, I can find out from the chap that deals with it.
Well, I think what I'll do, I'll ring Rover up and find out what the situation is latest from their end.
Yeah.
Because if anybody's going to know, they're going to know, aren't they?
Yeah, until somebody's took over the company and agreed all new trading agreements, basically we can't deal with them at all.
Terrific, isn't it?
I know.
Okay, Mike.
Okay, sir.
So the 12 we got is what we're getting, and we better hope that they get going again, quick.
Well, yeah.
Yeah?
Yeah.
Okay.
Okay, then.
All right, Mike. Cheers. Cheers. Not solved. Oh, dear. Oh, shoot.
You can tell from his body language if things aren't going too well. And sometimes I feel quite sorry for the person at the end of the phone and almost feel like phoning them up and saying, well, don't worry, you know, it's like that with everybody. But he's been quite a character. Also, his knowledge of areas of the product, which we didn't have before, has been very, very useful. Generally, we've concentrated on the major items in cars. He has a tremendous knowledge of the other little bits and pieces which are so essential to make a vehicle totally complete.
The parts buyers were also working to incredibly tight budgets, which called for some careful manipulation of those, mainly the styling team, whose tastes were a little expensive.
I spoil the party all the time because I keep telling them they can't afford what they want. You have to use a bit of your craft, you know. If you've got a component where maybe it needs a sexy finish on and you've had it done one way and it's cost £2 and you've had it done another way and it cost £5, you put the one that cost £5 in your pocket and say, it's going to look like this, lads. And then you get what you want, and they're not disappointed because they don't think they can get anything better.
In March, the Elise was ready for its official top speed and 0 to 60 trials at Millbrook.
Okay, here you can see the lights Caravet system. It produces the light which shines onto the ground, and as soon as you start off,
It measures speed and distance. And this is all connected through these wires into the lights box of tricks, which is operated by the laptop computer. It's my first time I've used this laptop on here. We'll have to see how it goes.
Everything all right?
Well, I don't know. It's a bit confusing. That was only really flashing 4.2 miles an hour. Didn't I tell you this is going to be problems? It seems okay, except that looking down at the screen when you're doing it, that's showing about 4.2 miles an hour. Well, it sometimes shows 3 miles an hour, and you're doing 120.
How'd you get on?
Well, we've still not got a lot of luck because it's making this silly noise again, and the speeds are just as consistent as they were last time, and nowhere near the speeds that we're doing.
Right,
it seems to me there's some sort of conversion factor we're missing here.
Software problem.
It's a software problem, sure.
Yeah.
Which is, well, about as far as we go, isn't it?
Yeah.
After borrowing some different equipment from Millbrook engineers, Dave Minter had a third attempt at measuring the car's acceleration from 0 to 60.
That's more like it. 5.81. That's better. I believe that. Much better.
Yeah. So
117.
So what was wrong with the equipment then?
It's not the equipment, it's the way you push the buttons.
Outright error, is it?
When it's flashing, you just go.
Yeah.
And it just does it. I was pushing it again and then going.
Oh, so you.
So what it was doing is taking the time from when when it started flashing. So
that's better. Yeah. That's better.
585.
Oh, pretty consistent, yeah.
578. I got 6.1 when I got one. But anyway, it's pretty good.
Yeah, so many runs is that?
I got 1, 2, 3, 4, and one in there was 5.
Is that enough? Doing there, yeah.
Yeah. Gearbox is taking a bashing.
It sounds like it, yeah.
An afternoon on Millbrook's high-speed track ended in good news, a top speed of 127 miles per hour. But there were no celebrations for another member of the team at the chassis suppliers in Denmark.
I just want to get on the first flight out of it.
Right.
And I'll speak to you when I get back, sort of in more detail.
Lotus has had to join forces with a number of other companies to develop the Elise. Most of these strategic partnerships have worked very well.
Part of the appeal of the Elise is that you have to be slightly athletic to get in and out the car and develop a technique. And it's very interesting. I went to the motor show on one of the Sundays. I took my family up, and I stood out in the crowd just sort of listening to the comments. And there was this poor old guy trying to get into the car on the stand. I mean, he was really in dead trouble. And the guy who was standing in front of me turned to his mate and said, whole fight. He said, it's too old to be getting in one of those. and that was it, and it just summed it up. So if there's any questions, I will be delighted to try and answer them.
What were the key factors in actually the selection of the Rover powertrain for your product?
Basically, size and weight. I believe that the Rover K series is the lightest four-cylinder powertrain unit on the market. And I would say cost, but it's turned out to be so expensive that that we wouldn't have selected it on that basis.
Rover is far more process orientated, far more concerned about doing things very correctly, and you know, Lotus is much more on the edge of technology, on the edge of failure maybe. So getting the cultures right between the two companies, the relationship, has been quite a challenge.
Yeah, we had quite a few jollies, various locations in the country. I think there was one particular one where we had to basically form teams, and they were joint teams, Lotus and Rover, and we had to build this thing that looked like a roller coaster and design it and plan it, and then come and build it the following day to a set of instructions with a minimum amount of material. And I remember the people who ran this management course, when we came in the next day with our inventory of what we needed to build this thing, they just shook their heads and said it's totally impossible. It's a third of the amount of stuff that anybody's ever used to do this before. And we achieved it quite comfortably and within the time. And basically we did that by reading the rules in a different way to anybody else having read them.
Hydro Aluminium in Denmark are major partners in the Elise project. They're experts in producing aluminium components, but have only recently set up this factory to build whole vehicle chassis. The Lotus chassis components are formed by squeezing billets of soft, heated aluminium through a complex die to form extrusions. The parts Lotus designed have pushed the process to its limits, and a problem seemed to have arisen at the point where a new billet of aluminium joins the one already in the press. Discoloration at the join was then squeezed through the length of the extrusion and could be seen when extrusion was sliced into individual components. The effect, known as charge welds, was explained to project manager Tony Shute by chassis engineer Darryl Gregg.
And the problem is characterised really by the change in colour. I don't know if you can see that little change in colour just here between this area of the extrusion and the general extrusion along here and here. I'm worried about this because it could represent a weak point in the extrusion, if indeed it is shown that we have a charge weld effect locally.
That's the first I've ever heard of this phenomena. And is it significant?
Well, it's the first time that Hydro have seen such extensive charge welds running through their extrusions.
Right.
And they're asking us the question, is this okay? And I think we're turning the question around and asking them to provide evidence of the microstructure of these areas and telling us whether it's okay or not.
In Denmark, Peter Wainwright had been having a frustrating time problem-solving at the Hydro factory. In March, he rang his boss in desperation.
Andy Plevin.
Andy.
Pete, how you doing?
Pretty bad, really.
Why, what's up?
I think I've come to the end. I'm just not getting through to these people. I'm just getting so frustrated that it's just causing me grief.
And you've tried all the usual people and the usual issues?
Yeah. I'm just getting fed up of sort of like telling people or advising them or trying to help them to do something. They take it on board, go away, and you check a couple of days later, they haven't done it.
I still believe that there's a communication and culture problem. There are differences with Scandinavian culture and English or Western Europe, and I certainly feel there have been communication problems. There must have been.
Yeah, I don't want to dump it on someone else, but perhaps it's an option. You know, let someone else have a go, see if they can see it with a fresh pair of eyes. But
perhaps we need a little more presence and a little more push further up the tree as well, and it begins to get very difficult, doesn't it?
Yeah.
Okay, mate. Well, you come back as soon as you can. Give me details of your flight when you've arranged it.
Well, I need to speak to Maxine.
Okay.
I just want to get on the first flight out of it.
Right.
And
okay.
I'll speak to you when I get back, sort of in more detail.
See you whenever. Okay,
Yeah.
mate.
All right.
Cheers.
Cheers.
After a couple of weeks' break, Peter returned to Denmark to see chassis production steadily improve. Hydro Aluminium have declined to be interviewed about the Lotus project. In the United States, the Langside Corporation had developed revolutionary lightweight brake discs for the Elise. Very late in the programme, Lotus discovered cracks in the discs, which are made from a mixture of aluminium and ceramics. Only a redesign and expensive retooling would solve the problem.
The Lotus disc is in its second design. The first design was very flat to fit within the envelope afforded by the car. The braking plates and the hub are very much in the same plane. This causes something of a problem when the friction is being applied to the brake plate and the brake plates try to expand. This expansion causes stresses in the hub, and so this particular design develops quite high stresses in the hub area. The redesign, which joins the hub to the other brake plate so that there is a hat or an offset within the disc. This allows the brake plates to expand and does not place too much stress on the hub in the hot condition. And this is a solution which stays within the envelope of the car, allows for some offset, and eliminates the high stress situation in the hub. We made the prototype discs here using a sand casting technique, and currently that's the product we're providing to Lotus. We have a vision of the future, if you like, that a better process, a better way of achieving the final product is not to cast the mixture into a shape, but to take the ceramic or the reinforcing elements of the composite, form them to a shape, and then introduce the aluminum just into that shape by this process by which we call infiltration. And this molten metal infiltration process allows us to have the shape of a disc, which is very close to its final form, introduce the metal, and finish up with a part that needs very little machining, maybe none in the final design, the final vision of this, perhaps no machining except a smoothing of the braking surface itself.
In March, Dave Minter and Tony Shute took 2 cars on a long drive over 1,000 kilometres to the French ski resort of Chamonix, a base for somewhat delayed winter testing in the Alps.
Well, from my aspect, I don't often get the opportunity to spend a reasonable amount of time in the car. I think if you're not very careful, you end up doing short trips in Norfolk, 20 minutes, half an hour, and you miss an awful lot of what's going on with the vehicle.
You have to put yourself in the picture of a potential customer. Driving it in Norfolk or just, for driving it for an hour at a time, you don't live with the car. And it's important to be able to live with the car. Can I get the bags in? What's annoying? I can't find anywhere to put this particular, put my sunglasses when I'm driving along. Things like that make the car a good car.
It's considered very much as a sporting type car and maybe not very practical, but I'm not sure that's the case actually. It turned out to be a lot more practical than I was expecting. We've done like 1,000 kilometres in a day, or we do 2,500 in 4 days, and it's very, very comfortable, it's quick, and it's very, very fuel efficient, which is good. We actually averaged, as discussing yesterday with Dave, 50 to the gallon over a 100-mile section of the autoroute, just driving at a constant, or averaging 65 miles an hour. That's not really a reason for the car, but it's kind of interesting, and if nothing else, it means you don't have to stop so often to fill up.
the ride differences between the two cars, what's your impression of the yellow car?
It's poor, very poor.
And in what aspect?
It's the harshness levels really, because the tyres on that are better than the summer tyres. So when we put summer tyres on, it's going to be even worse. And that's the worrying thing that I was talking to you about when we went to do the performance testing. Whereas you get into this car, and the isolation is much better. That's 4.5 points better.
So that's come with the change to the plastic bushes, yeah?
Yes, it has. When it's been rebuilt during the last week, that's changed completely.
And the best thing we can do is actually measure them in the wishbones.
That's the only way to do it, yes.
Check exactly what each car has got, and whether we end up putting those wishbones on there. I mean, it's just a mega amount of work again, isn't it?
Very much so, yeah.
Right.
And the cars are off the road again.
Now, the other problem this car has got is this sort of knock rattle from the back.
Yeah.
It's not under the extreme bumps, but under sort of intermediate bumps.
Yes, yeah. It sounds like you can imagine the bush housing on the damper hitting the mount.
Yes, the outside of it.
Yes,
yeah.
But I'm sure it's not happening because we've checked it so many times.
There's no witness marks.
No witness marks at all. But that's exactly the sound that you'd hear.
Okay. I'm also wondering whether it's not some bodywork that's bottoming out, like the doors or the clamshell or whatever.
Well, certainly on that car, there's a lot of bodywork noise, vibrations and crashing through on the bodywork. And I know that when you drove the car around without the clamshells on, you were saying actually that was quite quiet.
It was.
Yeah.
And you did use it for a couple of laps in the circuit.
Yeah.
I don't know if you noticed any difference there.
We drove up and down the yard, and it was quite good.
Yeah.
It's a bit too extreme without the doors, I think. What I'd like to do is drive this car without the rear clamshell on. So get rid of this, get rid of that, and see what happens.
Yeah.
Because if it's still there, because you'll get it on the circuit or off the circuit at Hethel.
Yes.
It's exactly that sort of input.
Yeah.
More design changes meant more delays and more frustrations on the assembly line, where 7 pilot cars were being built as a kind of rehearsal for proper production. Building these cars was supposed to help the manufacturing team set up a system which would deliver the right parts to the right point on the line at the right time.
We're now into the pilot build phase, which is going to enable us to train the operators and to iron out any bugs in the line. We've now completed the first of the 7 cars, which is short of parts because we haven't got parts into the latest specification due to design changes that we've found from problems in build, and that we haven't got new parts in from the suppliers yet. There's around 120 parts short on the first red car. Some of the parts have had to be redesigned because of fit problems, where parts don't fit together as they've been designed. We find that people that work on different systems on the car, maybe on body or chassis, haven't talked to each other enough, and they've put parts in each other's way, so you can't fit 2 parts in the same place, obviously. It's very difficult and very frustrating to try and drag the parts out of people. You know, they don't seem to realise the importance. You know, they see the cars dribbling down the line as if it were another phase of pre-production build. They don't seem to realise that we're under great pressure out here to build cars. If we slip the 3 weeks now, that's going to be 60 cars we lose off the end of the year when we're building it at 20 a week. And that's obviously big revenue to the company. So there's a lot of pressure for us to get into production now, but you know, we can't do it without parts.
Good morning, it's Ken Lotus.
Come in, Ken.
Okay.
Another big issue we have with the car before we can sell it is it has to be type approved. It has to meet the legal requirements for each of the countries. Now for Elise, principally we're looking at the European markets, also Australia and Japan, but not the USA. So we have to meet all those requirements. Now one of the positive things that's come out of the EEC is they've now got a universal regulation whereby if you can get type approval into one country, then that applies to all the other countries within the community. Now we've elected to do this in Holland because they were involved in the project from day one.
Well, I have to carry out the rules, of course, and if it doesn't comply with the regulation, it has a non-compliance, and the work has to be done again. But doing this work is always a cooperation between a manufacturer and the testing facility. And I think our goals may be a bit different, because I want the car to fulfill the requirements, and the manufacturer wants the certificates with as little effort as possible, of course, because it costs money.
This is the first car that Lotus have done, and also one of the first cars in the motor industry that has gone through this complete type approval process. It's a very intensive program, very expensive as well, so you need to get it right, and right first time.
As well as carrying out their own detailed examination of the Elise, the Dutch authorities studied film of crash tests which took place in England.
And there's a series of crash tests, but the main one is the 30-mile-an-hour barrier test, where the car is run up to 30 miles an hour and driven into a solid piece of concrete. And then this is filmed with very high-speed cameras, and you analyze what moves and what happens on the tests, and you measure the deceleration of the occupants and other bits and pieces in the car. And we were very pleased with the performance of the car, because effectively we could just take off the front crash structure, just delaminate it and bond on a new one, and we could have driven the car back to Lotus in Hethel. This car is particularly aimed at motorsport, and it's not unknown when you go racing to have accidents. The actual crash structure at the front, which is a sacrificial part, you can just unbond and stick a new part on. So those sort of repairs are relatively low cost, and even for the owner who enjoys working on his own car, some of these tasks are not beyond his capabilities, for sure.
Another problem is further down this line. As soon as you come here, it only touches the surface.
Yeah. Well, that will actually be blunted.
Yes.
The edge of this stainless steel strip.
Right.
The strip, which is used for attaching the soft top, was considered too dangerous, and the Dutch inspector ordered a design change.
Hello, Dave Barrett.
Oh, hello, Dave. It's Ken Evans here. I'm over at RDW in the Netherlands.
Hello, Ken.
As you know, I've got the Ruby car over here at the moment.
Sure.
And we've just got a small problem regarding the exterior projections of this vehicle at the moment.
Really?
Yeah.
Which area?
So. Well, you know the steel strip that goes along the top of the windscreen header rail?
Yeah. The retainer for the soft top?
That's correct.
Sure.
Yep. Although we have radiused the edge, smoothed off the edge of that strip,
sure,
it's not really as good as it could be.
It's not complying?
So, no, well, yeah, that's it.
We'll have a look at it and understand your problem a bit closer in detail.
Yeah, but we've got a time constraint on this, and what I would like to do is I want to present the RDW with a positive a view of how we're going to fix it.
By when do you need to know?
Well, ideally, I'd like to know at the end of this week, but if you could come back with Friday morning, then at least I could give some sort of positive idea of what we're going to be doing.
Okay. Right, then, I'll do that. I've got your number, so we'll be back to you tomorrow morning and hopefully see the best way of resolving the problem.
Okay.
Okay.
Yep, thank you very
thanks,
much.
Kim.
Goodbye,
Cheerio.
Dad.
By June, Hydro in Denmark were having much more success bonding or gluing the aluminium chassis.
When you walk through their production line, they happen to be welding a structure for another client. And you walk through and there's grinders going off, and there's sparks flying, and there's dirt and noise and muck. And as you go through the factory, you sort of quiet and stand, and then there's a glass partition, and there are people in there with white coats on, gloves, picking up the pre-machined extrusions, placing them into the assembly jig, applying the glue, applying the rivets, and it's dead quiet, it's peaceful. It's a much nicer thing to do. The energy required, I think, in the bonding process is a lot less. The accuracy is much greater. A very attractive thing for the rest of the automotive world.
The Elise's bonded aluminium chassis is an industry first, and it's created in unique, almost clinical conditions. The main priority is to prevent any airborne contaminants affecting the adhesive, so the air pressure inside the production cell has to be kept higher than the rest of the factory, so filtered air seeps out and contaminated air never seeps in. Danish health and safety laws demand that the epoxy-based adhesive never comes into contact with skin, so the technicians are forced to wear gloves and protective clothing. The chassis is made from over 40 separate extrusions, and when it's moved from the assembly jig, the glue is still soft. It doesn't harden or become safe to touch until the whole chassis has been cured in an oven at high temperatures for at least 4 hours. Peter Wainwright, who at one stage had serious concerns about the supply of chassis, is now much more confident.
Oh, I believe things are over the top of the hill and we're skiing down the other side. I mean, we're in production now. The supply of chassis is good. The way a lot of people are working there is a lot better now. I mean, back in March, towards the end of March, I couldn't see a way forward. I want to see it through to the end now.
See the side rails back there now, where that was dipping down?
Is that improving?
It's a lot more level round the back here. So that's good.
Lotus hopes the strength of its bonded chassis will convince other manufacturers that it's perfectly acceptable to glue cars together.
Well, I think it's how you portray it, really. I mean, airplanes are glued together, as you put it, and nobody worries about flying off over to America with a wing that's glued onto a jumbo jet. That's quite normal. And the same with racing cars. I mean, the racing car tub is basically just glue and a fibre. And as we've seen from some of the accidents you see on television with Formula One, the integrity and strength of those tubs are just unbelievable.
So for Lotus to bond, I'm sure, will lead to better things for Lotus. We're now a huge step ahead of anybody else. And with our knowledge, we'll be able to go on and make other cars with more complex structures, but this is a great starting point.
In June, somewhat later than they'd been promised, the motoring press finally got their chance to drive the Lotus Elise. Completed cars were still in short supply, so there was no razzmatazz, no glitzy press launch in the south of France, just a chance to drive and photograph the car for a day in the countryside around the factory in Norwich. Lotus has never gone in for expensive advertising campaigns to promote its cars. It knows that if new products live up to Lotus traditions of ride and handling, the enthusiasm of motoring journalists like Ray Hutton will promote the car for them.
I wonder whether people generally would want to have a car that has so little room in it there, because the two of us are sitting there with our shoulders rubbing together, and that might be quite nice for some people, but I don't particularly want to do it with a photographer.
And I'm just going to finish off on the nose here.
Okay.
Badge and headlights, etc.
Well, that only has the same power as an MGF. It's a good deal lighter and therefore considerably faster. Brakes are extremely good as well, but no servo. I suppose that's part of the good response. No power steering, of course. And we've all got used to that in recent years. And so to go back to something which is really a sort of raw, basic sports car, but which is so well done, is really, really fulfilling.
Can I get you to tilt that mirror up, right?
Yeah.
That's perfect.
I'm not getting a picture of you in it as well, are we?
Only.
And I'd like to have somewhere a little bit easier to put my briefcase or something if I was going to use one on an everyday basis. But I suppose that's the point. People aren't really. Most of them are going to buy it as a second car just to use for fun at the weekends. And good luck to them. It's really nice.
The Elise had unprecedented reviews in the motoring press. Autocar dubbed it the 8th wonder of the world. Car magazine enthused, it's so fast, so agile, so pure, and added, the 21st century sports car is here now. The press reviews led to a flurry of orders from customers, and by the end of July, 1,300 people had put down £1,000 deposits on the car they had never seen in the flesh, let alone driven.
One of the equations we've got to sort out very quickly is the question of supply and demand. We originally underestimated, I think, the level of demand that there would be for this little car. This year, the first year of production of the car, we were going to actually build just 400 cars. Of that 400, only 200 were going to be for the UK, so a tiny, tiny number. Next year, we were originally looking at building 900 cars, again, of which probably half were going to be for the UK market, with the rest for mainland Europe and the Far East. It now looks as though we have considerably underestimated that original production objective, and our chairman has recently stated that he's looking to increase production up to 2,500 vehicles a year.
At the moment we're producing one car a day down the assembly line. We've got a few cars off the end of the line which are just waiting for the finishing touches before we can pass them off to the dealers. We're currently training new staff so we can increase the volume to 2 per day at the end of next week. Following on from that, we'll be going up to 3 a day, and very soon after that 4 per day, which is our maximum production rate. We were very frustrated early on with the short programme and late release of parts. Not being able to have the parts online to build the car in sequence was very frustrating, but at the end of the day we overcome the problems one way or another, either by hand producing parts to get us out of a muddle to see how things fitted together before the production parts came in. But yeah, it's pretty good. We've still got a few little engineering issues to sort out, but nothing that will stop us selling the car.
But 2 weeks before the first car was due for delivery to a customer, the whole company was rocked by a boardroom revolt. Lotus Cars and the more profitable Lotus Engineering division had been on the market for a year. Potential buyers had raised doubts about the future of car production. In a bid to end the uncertainty, 4 directors and the company secretary confronted the chairman, Romano Artioli. All 5 of them were suspended.
Well, on the Friday, what happened was that the board that we had decided to try and force the pace in terms of sale of the company, and gave Mr. Artioli an ultimatum. And Mr. Artioli doesn't like ultimatums, and responded on the Tuesday by bringing in a bunch of lawyers and effectively marching them off the premises. It's typically Lotus. I mean, Lotus never does things the easy way. We've had this huge bank of good publicity, and we're on a roll, and then suddenly we have this. And I think it's just very character-forming.
On August the 1st, P-registration day, with the future of Lotus Cars still hanging in the balance, one of the country's oldest Lotus dealers in Surrey was given the opportunity to sell the first Elise to the first customer, Lotus enthusiast and driving examiner Jeff Prescott.
Richard Rackham, Andy Hill from the design team.
Yes. Yeah, was it Hazel? Is it? Yeah. Oh, great. Yeah, right.
From a stylist's point of view, it's just a dream come true to see a product right through from first sketches right through to seeing a customer drive the first car away. It's a real honour.
I gather you sort of ordered quite a long time ago, didn't you?
It's now 25 months, I think. Yeah, 25
And we didn't
months.
even have a name for the car then, did we?
No, there was no car, no names, no.
I remember there's a night when we were photographing the car for the brochure. The car was parked there and we weren't allowed to get near it because they were photographing it, and so we only could stand back and look at it. So spiritually as well. And, we suddenly realised we'd created much more of a car than we'd actually thought we were going to. It was actually better than we thought it was going to be. It had more content, it was more real, it was cleverer than we'd ever imagined. It was very, very satisfying.
I think we ought to propose a toast to the new car and to our first customer.
Thank you very much.
To Elise.
Elise.
2 years-ish from start to finish, for cars coming down the line, and I can't believe that there's other car manufacturers that could turn it around that quickly. I don't know, it's been a struggle, but that's what Lotus is all about. It's about innovation and keeping things small and doing it quickly and giving the customer what they want.
That sort of thing, yes. Smile.
Thank you very much.
I think the technology side of it is very significant in that we've learnt so much from some of these bits and pieces. I'd love to go and do another car. And who knows, it might be an off-road vehicle, might be a MPV or whatever, but using this technology, and that's where it's significant, because we understand now the process of doing aluminium structures, we understand how to design MMC brakes and how to do uprights and so on, and they can apply to all sorts of vehicles. I think it's another way of making a car.
At the end of Project M111, the Elise weighs in at 690 kilograms, 2/3 the weight of a Mini. It boasts a top speed of 125 miles an hour and accelerates from 0 to 60 in 5.7 seconds, with an on-the-road price of under £20,000.
Off we go. I don't know why come back. Supposed to check on.